So now let's see some slightly more complicated examples of equations and see how to deal with them. Right, in this case we have an equation with x and there are two x's, one at the top of a fraction, one at the bottom. So when we have something like this, your immediate thoughts should be, how do I get rid of the x in the denominator? Okay, so you should not so much worry about the numerator. Your focus should be on getting rid of that denominator with an x in it. And here, the easiest thing to do is just to multiply both sides by x minus 5. Because if we multiply the left by x minus 5, effectively that denominator will cancel out. And then on the right, we'll be left with 7 times x minus 5. And at this stage, we can just develop, and then now it turns into a normal equation. We know how to deal with those. We need to regroup the x's on one side and the numbers on the other. So that's what we do. In this case, we decide to put the x's on the right rather than on the left. Why do we do that? Well, it just happens that we've got more x's on the right than on the left. So if we move them to the right, it's going to keep it positive. Whereas if we move it to the left, we would have things that are negative. We would still get to the same results. It's just that it's easier to keep things positive, and then at this stage, we can just flip things round and then divide by 6 to get the result. Okay, so here, the new aspect was at the beginning when we have a unknown in the denominator of an equation. The first thing we want to do is we want to try and get rid of that denominator. Now, let's see another type of problem we can have, which is with a square root. And here it's the same principle. We want to get rid of that square root as soon as possible. So what do we do in this case? Well, we can square both sides of the equation. We're allowed to do that because it's effectively the same operation on both sides. It doesn't change the equality. And by squaring the square root, we get rid of the square root. And we're left with x plus 3 equals 25. And at this stage, we can just solve like a normal equation. What happens when, well, the square root is not on its own? Here we have to be a little bit careful, because if we square both sides of this, well, you can try it yourself, you'll have a cross product that appears, and you won't be able to get rid of the square root. So what you need to do first is isolate the square root of x. So we do that by minusing 2 on both sides, and then we square the result of that. So we're left with x equals 5 squared, which is 25. Now, the last case we want to do is the case of absolute values. And again, similar principle, we want to isolate it, and then we want to square things. So in this case, we move the 5 over to the right, we square both sides, and squaring an absolute value actually gets rid of it. Why? Because an absolute value, what it does is that it turns a negative into a positive, and it leaves a positive as is. So effectively, it doesn't change anything else than the sign, but the square of something is always positive, and therefore we can just forget about the absolute value. It has no effect. And then at this stage, we get a normal equation. So in this case, it's a quadratic equation. So, I mean, you could argue that it's not completely normal, but we know how to solve that. We just have to regroup everything on one side and then apply the normal formulas. So there is one last case to see. So sometimes you have an absolute value and you don't want to square it. So there could be various reasons for that. We'll see some examples in other videos. But there is another method that you can use, which is to consider two different cases. So an absolute value, its impact depends on the sign of what's inside it. So if that thing inside is negative, then it turns into a positive. So minus 3, absolute value of a minus 3, becomes plus 3. Okay? Absolute value of plus 3 just says plus 3. Now the problem here is that we have this x minus 3, so we don't know what x is, and depending on what x is, the whole thing could be negative or positive. So we consider a first case when it's positive. So here we assume it's positive and we kind of act like it is. In that case, if it's the whole thing x minus 3 is positive, then absolute value of that is just itself. We can get rid of it. And then we solve normally to get x equals 8. The other case is when what's inside the absolute value is negative. Now in this case, what happens is it flips the sign. Right? Absolute value of minus 10 becomes plus 10. Flip the sign. So here we have to flip the sign, but we have to flip the sign of the whole thing inside. Okay? Very important to apply the minus both on the x and the minus 3. And if we do that, then actually this minus 3 becomes a plus 3. And again, we can solve this the normal way to get x equals minus 2. Now you're probably wondering, well, is the answer 8 or is it minus 2? Well, it's actually both. Or it's, to be more precise, it's one or the other. We just don't know. Okay, so both are possible solutions. It's just like if you're in a room and you're trying to exit via a door, if you have two exit doors, you have two possible solutions. Same principle here.